The gate shown is 1.8 meters wide, hinged on the upper end and restrained by a stop on the bottom. Compute the force on the stop and the reactions at the hinge if water depth H is 3 meters. The gate is made of steel, specific gravity 7.85, 25 mm thick. Then second situation, if the stop will break, if the force on it equals or exceeds 45 kilonewtons, for what water depth H is this condition achieved? So this is the figure, that's the depth, 1.2 height of it. Then let's draw the normal view of the gate. So it is 1.8 meters wide, 25 mm thick. This is the stop to prevent the gate from opening counterclockwise, and that's the hinge. So let's locate the centroid and the center of pressure. So the centroid is in general half of 1.2 is 0.6, so this is 0.6. So H minus 0.6 barred H. Then call this E sub V, distance between centroid of area and center of pressure. At the center of pressure, the force, hydrostatic force acts. Then at the centroid acts the weight. These are the component reactions, and this is the force on the stop. So we sum up moments about the hinge on top so that we can set up Fs. So the moment arm of F is 0.6 half of 1.2 plus E sub V. And this is the weight. And the weight has no contribution to the moment at the top because the gate has vertical surface. So Fs times 1.2 equals F times quantity 0.6 plus E sub V. So this is our working equation, where F is 9.81, quantity H minus 0.6, where H is 3 in the first iteration, so 2.4, then area 1.8 by 1.2. So F is 9.81, 3 minus 0.6, H minus 0.6, then area 1.8 times 1.2. So F is 50.86 kilonewtons. E sub V, on the other hand, is height of rectangle square over 12 barred H, or I sub CG over area barred H. This is the simplified formula. Height of rectangle square over 12 barred H, and barred H is 3 minus 0.6 or 2.4. So E sub V is 0.05 meters. So substitute, we can now solve for the force on the stop. Fs times 1.2 equals 50.86 times quantity 0.6 plus 0.05. So F sub S is, force on the stop is 27.55 kilonewtons. And next is reactions at the hinge. So we sum up moment about the stop to solve for Hx. And the moment arm of F is 0.6 minus E sub V this time. So Hx times 1.2 equals F 50.86 times quantity 0.6 minus 0.05. So this is centroid to bottom is 0.6 minus E sub V, so 0.6 minus 0.05. So Hx is 23.31 kilonewtons. Then Hy, summation forces y, Hy would be equal to the weight. And the weight is 7.86 specific gravity of steel times 9.81 times volume of gate, which is 1.8 times 1.2 times 0.025, the thickness. So 7.86 times 9.81, specific weight of steel, volume of gate, area 1.8, 1.2 times 0.025. So Hy is 4.164 kilonewtons. In the second part, the stop will break if the force on it will exceed or equals 45 kilonewtons. So Fs is 45 greater than equal to 45 kilonewtons so that the stop will break. And the working equation is still the same. Fs times 1.2 must be equal or greater than F times 0.6 plus E sub V. F will now change. F is 9.81 times barred H minus 0.6. area 1.8 times 1.2. So simplifying, F is 21.19, H minus 0.6. Then ISA V is 1.2 square over 12, quantity H minus 0.6. So simplifying, ISA V is 0.12 over H minus 0.6. So substitute in this working equation here. 45 times 1.2 must be greater or equal to 21.19 times H minus X times quantity 0.6 plus ISA V, which is 0.12 over H minus 0.6. So simplifying the right side, 21.19 times 0.6 and multiplied by H minus 0.6, then 21.19 times quantity H minus 6 times 0.12. So we can cancel H minus 0.6, 0.12 over H minus 0.6. So that's a whole number. That's a value. So 54 must be greater than 12.714, quantity H minus 0.6, plus 21.19, this factor here, times 0.12 over H minus 6. So 21.19 times 0.12 only 2.5428. Simplifying further the right side, 54 should be greater than 12.714H minus 5.086. So finally, H is 54 plus 5.086 divided by 12.714. So H should be less than equal to 4.647 meters, so that the stop will not break. Beyond this value, the stop will break. That's it.